Evening everybody. Today we will discuss the benzylic substitution reaction. So as we discussed in the last class, the benzylic nucleophile substitution can be classified into SN1 and SN2. So in the SN1, you know that the nucleophilic substitution reaction undergo through a carbocation, formation of the carbocation. Here in this example, our substrate is C6H5CH2Cl and the chlorine is the leaving group. And chlorine is liberated from the reaction site as Cl- ion. So a benzylic carbocation is generated. And in the benzylic carbocation, the positive charge does not locate in a one single carbon atom. It may undergo the resonance structure. So these are the resonance structures of the benzylic carbocation, and we can see that there are 5 resonating structures are possible for the benzylic carbocation. Now in the SN1 reaction, as you know that the carbocation has a planar structure since its hybridization is sp2. So the nucleophile can attack to the reaction center, that is carbocation, either from the top face or from the bottom face. So we will get a 2 product. So consider this example I have shown in the bottom of the slide. C6H5 carbon which is attached to the one substituent as bromine and other substituent as methyl, and other substituent is the CH2CH3. So here the benzylic carbon atom I have shown by the number 3. So the benzylic carbon atom is attached to the two substituent Br CH3 and CH2CH3. So in which bromine is the best leaving group since the Br is a bulky group and it is Br minus is stable. So the Br is liberated from the benzylic group as Br minus. So reaction center become benzylic carbocation, and the nucleophile can attack the benzylic carbon atom either from the top face or from the bottom face. So we will get 2 product. So the reaction mixture is a racemic mixture in the case of SN1 reaction. Whereas if the same reaction undergo through the SN2 reaction, as we discussed earlier, the SN2 reaction undergo through a transition state. See in this example, chlorine is the leaving group and SH minus is the nucleophile. So the chlorine approaches the benzylic group in the opposite side of the leaving group, and after the liberation of the leaving group we will get a final product at benzylic thione. Now we are moving into the next topic, that is ambident nucleophile. So usually in a nucleophile there is a one single atom which is used for the coordinating the reaction center. So ambident nucleophile means it is a nucleophile having 2 nucleophilic sites and they are ready to attack the substrate. So for example, in the nitrite ion, so nitrite ion can be written as O minus nitrogen double bond O. So in which there are 2 nucleophilic atom is there for coordination. So one is negatively charged oxygen, the other one is the lone pair of electron located in the nitrogen. So here there are 2 attacking site in the nitrite ambident nucleophile. One is O minus, the second one is the nitrogen. So if it undergo the reaction, we will get 2 product, alkyl nitrite and nitroalkane, but one of the product is the major one. See the example. In the reaction column nitrate synthesis, the starting material is RCH2Cl, that is an alkyl halide, and here the nucleophile is KCN, and KCN is a ambident nucleophile, and there are 2 atoms to attack the alkyl halide. One is negatively charged carbon and the second one is the lone pair of electron which is located in the nitrogen. So if it undergo the chemical reaction, we will get the final product, major product, as RCH2CN. But there are 2 possibilities. First one is the cyanide group attack the reaction center through negatively charged carbon atom. So we will get a cyanide as the final product. But it may also can attack through the lone pair of electron located in the nitrogen. So we will get an isocyanate. Our major product is the RCH2CN. Okay, I hope that you understood the concept of the ambident nucleophile. Now, there are some factors which affect the reactivity of the ambident nucleophile. First one is the polarity of the nucleophile, and the second one is the nature of the solvent used in the chemical reaction. So, you know that there are two atom is present in the ambident nucleophile. Depending upon the electronegativity, we can classify these two atoms as hard and soft. So according to the HSAB principle, hard base will always react with hard acid, and soft base will always react with soft base. Soft acid will always react with a soft base. So in these two atoms, most electronegative atom is considered as a hard base. So it will attack the most electropositive atom in the reaction center. That is, according to HSAB principle, hard base will always attack the hard acid. And next factor is the nature of the solvent. If we use a polar protic solvents, there may have the possibility for the hydrogen bonding to the most electronegative atom in the ambident ligand. So the least electronegative atom, that means less electronegative atom, is more free to attack the reaction center. So if you are using the polar protic solvent, least electronegative atom will attack the reaction center. But if we use a polar aprotic solvent, there is no possibility for the hydrogen bonding, and there is no interaction of the solvent and the atom. So more electronegative atom is free to attack the reaction center. So these are the factors which affect the ambident reactivity of the nucleophile. I hope that you understood the concept. Thank you.